Hello everyone. I am Vishnu and my teammate is Rohit. Our project is analysis and detection of phishing websites. Here are the contents of the presentation. Phishing is basically a process in which an attacker tries to obtain sensitive or important information from a victim. The attacker might use any of the means like emails, tests, or websites. Among these, websites are the most common way attacker used to commit the information thefts. A phishing website has the same look as the legitimate site, but the backend is designed to collect the information input by the victim. Our project here is the analysis and detection of phishing websites based on website URL. We have taken two datasets from Mendeley data for phishing websites. URL-based analysis considers factors like domain lookup response time, number of redirections, etc. in the process of detection. We have developed an algorithm that does all the stated objectives. However, we have not developed the front-end part, and hence the output of this project gives the accuracies of all the algorithms applied on the dataset. Modules. These are the modules in the project. Data collection, literacy survey, exploratory data analysis, machine learning modeling, model metrics, and fitness checking. Machine learning models. We train the dataset to a variety of machine learning algorithms, namely KNN classifier, logistic regression, decision tree classifier, random forest, multi-layer perceptron, gradient boost, ADA boost.
Hello everyone, I'm Rohit and I'm going to take you through the code of the project. So here is the code for the project. We initially have imported some libraries required for machine learning codes. The basic libraries are pandas, numpy, and scikit-learn, also known as sklearn. So in sklearn, we have all the algorithms required to implement the code. So we also import certain metrics like log loss, confusion matrix, recall score, precision score, and accuracy score. So I'm going to be guiding you through the code. So I've already executed the code once. So accuracy and model are the dynamic variables in which we store all the algorithms applied and their accuracies respectively. So df train and df test are the data sets we have used to train and test split. So I have used the small data set to train and the large data set to test, but usually everybody likes to use small for testing and large for training. But in this case, the reason for which I have used in the reverse manner is, in this case, large data set is actually a superset of small data set. So large data set has all the values of small data set plus some zeros and some null values. So we basically do that and we print out the shape, that is the number of rows and number of columns in each of the data sets, small and large. So the small one has 58,645 number of rows and 112 columns. These 112 represents the URL parameters that we are going to check based on inputting the URL. So these are the numbers of the data sets. So we then train the X and Y variables, and we also deploy the test variables for X and Y. We also print out the shapes. What we're doing here basically is there are 112 parameters in which we decide the URL is phishing or not. Those are divided into 111 and 1, both for the training and testing dataset. The 1 here is the predictor variable, that is our result. So Y consists of the result. Coming to the next thing, we just print out all the shapes of the variables we just calculated here. So the first algorithm we're going to be applying is KNN classifier. As you know, machine learning has 3 types of learnings: supervised learning, unsupervised learning, and reinforcement learning. So supervised learning is what we're going to be concentrating on in this program. So supervised learning is further divided into two types. So the first one is regression and the second one is classification. So a classification problem has a discrete value as its output. KNN means K nearest neighbors. So it is a type of classification based on nearest neighbors. So K nearest neighbors algorithm assumes that similar things exist in close proximity. In other words, in simple words, similar things are nearer to each other. So it just runs on an assumption that similar things exist nearer to each other. So that's the concept behind KNN. So this part, the model fitting and the calculation part is same for every single algorithm. So I'm going to be speeding up there. So we just basically import the K-neighbor classifier from sklearn and assign it to the variable KNN. So we fit the KNN model to this variable, and I've taken the nearest neighbors to be 5 here. It can be more or it can be less. It's completely your wish. I've taken 5. And the leaf size is also defined by us. So KNN model is being fit to the train values. The Y predictor is being calculated here. So this thing is called the confusion matrix. So confusion matrix is just used to represent the true positives, true negatives, and false positives and false negatives of a data set. This is used to calculate the precision score, recall score, and accuracy score. So these are the things. So accuracy score is given out to be 86.44%, which is great, but not too good compared to the ones we apply below. So we have got the accuracy as this. So we append the KNN model to the variable model, which we have declared here. So we then proceed to logistic regression. So logistic regression, as the name suggests, it's not actually a regression, it is a classification due to its behavior. So in logistic regression, data is fit into linear regression model, which then is acted upon by a logistic function predicting the target categorical dependent variable. So there are 3 types of logistic regression: binary, multinomial, and ordinal, which I'm not going to discuss because it's out of scope. I have not used those things. So I've used basic logistic regression. And as I said before, we just fit the algorithm, we derive the predictor variable, and we calculate confusion matrix, and we derive these scores. Logistic regression actually gave out an accuracy of 92.2%, which is better than KNN, which was 89 something. So the next, we also append the logistic regression to the variable model, and we append it accuracy to the variable accuracy. So we append models and accuracy of all the algorithms we test, because we need to compare them in the last piece of code. I'll show you that. So the next is decision tree. This is quite famous. Most of you might know about this. So decision tree algorithm is basically a supervised machine learning algorithm that uses a set of rules to make decisions similarly to how humans make decisions. So decision trees can perform both classification and regression tasks. So you can often call them CART, C-A-R-T, meaning classification and regression tree algorithms. So the intuition behind this decision tree is that you use the dataset features to create a yes or no question and continually split the dataset until you isolate all the data points belonging to each class. So every time you ask a question, you're adding a node to the tree. And the first node is called the root node. So the result of asking a question splits the dataset. So if you decide to stop the process after a split, the last nodes created are called leaf nodes. So basically, the lowermost level of nodes are called the leaf nodes. So we just do the same thing with decision tree. We calculate the predictor, we do the confusion matrix, and we do scores. So decision tree actually gave us the highest accuracy so far of 99.14%, which is very, very rare. Accuracy over 95% is very rare. So it's got pretty good accuracy to this data set. So the next algorithm is, and as usual, we append the decision tree model and accuracy as well. So coming to random forest, like its name implies, it consists of a large number of individual decision trees that operate as an ensemble group. So each individual tree of random forest gives out a classic prediction, and the class with the most votes becomes the model's prediction. So this is just like politics. So the random forest consists of many number of decision trees, among which everything gives out its prediction. The prediction with the highest number of votes turns out to be the resultant prediction of the whole algorithm. So we do the same thing here. We fit the data set into the algorithm. We derive the accuracy score, and this here is the highest accuracy score we personally have got on this data set. So random forest is the most suitable algorithm on this data set. So we, as usually, append this. The next is quite new to me as well. This is multi-layer perceptron. This is actually the stepping stone to deep learning. This is the basic level of neural network. So a multi-layer perceptron is a neural network that learns the relationship between linear and nonlinear data. So a multi-layer perceptron is a class of, basically it's a class of feed-forward artificial neural networks. So feed-forward is a type. So it just means any feed-forward ANN. It sometimes refers strictly to networks composed of multiple layers of perceptrons. So we just do the same thing. We calculate the accuracy by using confusion matrix, and we got an output of 91.81%. So that's pretty good. The next algorithms I've tested are boosting algorithms. And among the boosting algorithms, I've tested gradient boost and AdaBoost or adaptive boost. So gradient boost is actually derived from, it's an improvised version of AdaBoost or adaptive boost. So I'm going to tell you AdaBoost first. So the code is the similar thing as before. So I'm going to tell you the model behind AdaBoost. So AdaBoost is like, it works by weighting the observations. It puts more weight on difficult to classify instances and less on those instances that are already handled well. So new weak learners are added sequentially that focus their training on the more difficult patterns. So as the name suggests, it's adaptive. So it just adapts to the situation and it concentrates more where it needs to concentrate more. So this AdaBoost framework was further developed by a guy called Friedman, and he called it the gradient boosting machines. So he developed AdaBoost into gradient boost. So we do the same coding thing. The code looks similar to all the algorithms, but the accuracy came out to be 95.6 for gradient boost, and it came out to be 93.7 for AdaBoost. So like I said before, we compare accuracies at the end of the model. So the model consists of all the models as specified here, and the accuracy consists of all the accuracies here. So you can see it clearly here, but it would be better if I show you in a graph. That's why I imported matplotlib, which is the visualization library for machine learning in Python. So I've given out all the algorithms